speeds of up to 250 kilometers per hour. A powerful hurricane like Katrina can release as much heat energy every 20 minutes as a 10 megaton nuclear bomb. While storms release heat stored in the ocean, the moisture they stir into the atmosphere helps keep the rest of the planet warm. Water vapor traps solar energy, along with carbon dioxide, the same greenhouse gas that ruined Venus. The difference is that Earth has found a way to keep CO2 in check. We can see it for ourselves by flying down to the ocean.
ನಾವು ಆಡಿಗೆ వెళ్దాము
మార్నింగ్ వెళ్ళాలంటే
అక్కడికి వెళ్ళి మనవాటికి బోర్డు వేసుకోవాలి. ప్రశాంతంగా ఉంటే బాగానే ఉంటుంది. అంత ప్రశాంతంగా ఉంటుంది తర్వాత ఏమైందని భయం వేసింది. ఓ
The special ingredient that sets Earth apart is called life. The oceans are chock full of it. Too small for our eyes to see. Phytoplankton may be the most important living things on the planet. They take in CO2, driven into the ocean by waves or drawn up from the deep by currents. They release the oxygen while absorbing carbon. The carbon then begins a journey up the food chain. Phytoplankton get eaten by zooplankton. To name a few, radiolarians date back to the time over 500 million years ago, when life exploded across Earth's oceans.
అవును వాడు చెప్పేది అదే చూడు ఫస్ట్ అక్కడి నుంచి ఇక్కడికి ఇలా వచ్చింది.
bug-like crustaceans. With over 20,000 species, they are the single largest source of protein in the sea. Moving up in scale is a host of creatures smaller than the tip of your finger, including these octopus larvae.
వీడియో వచ్చింది బ్రో హై క్వాలిటీ 4Kలో.
They get eaten by small fish, and they in turn by larger ones like jacks. They are consumed by the largest predators in the sea. Orcas, tuna, sharks.
వేలంటే
ఇవన్నీ షార్క్స్.
At each step in the food chain, the carbon that began as part of the diffused gas in the air is passed on to larger and larger animals. The larger the body, the greater the mass of carbon. One creature goes all out.
చిన్న చేపలాగా కనిపిస్తుంది.
వేలు.
A humpback whale eats up to a ton and a half of food per day. That's a lot of carbon. From whales down to tiny phytoplankton, marine life is part of a global system of removing CO2 from the atmosphere, then gradually releasing it back. The key to this carbon cycle is Earth's ability to store it long term. A NASA satellite tuned to read chlorophyll, a chemical tracer for plant growth, shows the global biosphere in action. In sync with the seasons, plants take in vast amounts of carbon dioxide and release the oxygen we breathe. On land, the carbon can then find its way into the ground when plants and animals die and decay. The earth too gets into the act. Exposed rocks take in CO2 when it rains. Erosion sends it into the oceans. If it becomes part of the marine food chain, carbon-rich matter can sink all the way to the sea bottom in the form of waste. Countless organisms, like the salp, a jellyfish-like creature the size of your thumb, live and die each year. All the waste, all those bodies with their stores of carbon, rain down onto the ocean floor. They pile up, layer upon layer. In time, these carbon-rich sediments can turn to oil or to rock, like limestone. The carbon can return to the environment as CO2 if the rocks become exposed, or if they get pushed deep underground by the movement of the Earth's crust, in a process known as plate tectonics. The pressure and heat gradually build until the Earth begins to erupt. Every year, over 100 million tons of carbon dioxide is spewed into the oceans and atmosphere by volcanoes. Acting on timescales of a day to millions of years, the carbon cycle has helped make our planet habitable. But its success depends on life itself. We are how Earth works. If somehow the carbon cycle went wrong, what would Earth be like? The answer is a world away, on Venus. Here, the CO2 belching from volcanoes isn't going anywhere. Venus is like a house on fire with the windows forever closed. The cause can be traced in part to those incinerating solar winds. Sheltered from those winds, Earth has kept CO2 levels in balance by absorbing and releasing it in roughly equal amounts. Lately, that balance has been shifting. The amount of carbon dioxide from human activities, including cars, power plants, and factories, now exceeds volcanoes by over 200 times. Much of that is from the burning of oil and coal stored in the earth for millions of years. Since the Industrial Revolution, the amount of CO2 in the atmosphere has increased nearly 40%, with most of that in the last 50 years. The result, global temperatures have risen by almost 1 degree Celsius. That's enough to accelerate the melting of vast stores of ice on high mountains and in polar regions. Since the 1980s, NASA scientists have methodically tracked the Arctic seasonal changes. They have found it's lost a quarter of the area covered by ice in summer. What's left has also thinned dramatically. That's just the beginning of changes that could transform our world. With some regions getting more rainfall, others drought. Deserts expanding. Natural fires becoming more prevalent. Wildlife habitat shrinking. Polar regions becoming forested. And as the ice melts, it drains into the oceans. By the end of the century, sea levels are now expected to rise as much as 1 meter, inundating coastlines around the world. As our impact on the climate has grown, we've also gained a new perspective on Earth. From space. Technology is allowing us to take stock of the elaborate interconnected climate systems that protect our world and sustain it. Within the fold of wind and water, of time and tectonics, our planet has nurtured another extraordinary participant, life. Today, we are masters of a world, revealing itself as more and more wondrous than we ever imagined. Even as we continue to explore its workings,
వచ్చింది దేనికి
we ask, is our goal to
నచ్చింది
spend
గుద్దామని
Earth
ఉంది నాకు.
or save it?
ఏది? వెళ్దాం వెళ్దాం అయిపోయింది అదిగో చూడు అయిపోయింది.
Okay, everyone, thank you. We hope you enjoyed the show. Be sure to exit up the stairs to the second floor.